we're going to do rates of change, and we're going to do some velocity. So if you're in physics, this might mess you up. I don't know. We'll see. Or it might help you. Hopefully it'll help you. All right. So we're going to do like 3 parts today. But they take a while.
10 minutes before.
Yeah, maybe. We'll see. We'll see. Okay, we're going to talk about the change in volume and area. Change in volume or area. And I think we've done these before a little bit. We touched on them. We touched on the last chapter where we had to take the limit as h goes to 0. So here we go. Number 1. Now remember, when you're finding the instantaneous rate of change, you want to take the derivative. The derivative is just awesome for that. So we're going to do a couple things here. We're first going to write the area of a circle. Write the area of a circle. Hopefully by now you know what the area of a circle is. Yeah? Yeah, you do. Area equals pi r squared. Perfect. Okay. So far we're doing great. All right, letter B. We are now going to find the instantaneous rate of change of the area with respect to its radius. Find the instantaneous rate of change. Okay, that's kind of scary when you see that. It's a big word, and it's like, what does that mean? Just remember, you just take the derivative, okay? So the rate of change is the derivative. It's the derivative of the area with respect to its radius, dA dr. You can write a prime. That's, the other way to write it. This is a better way to write it because it's showing you the change in area over the change in its radius equals. And what's the derivative of pi r squared? 2 pi r. Do you recognize that? Circumference. Okay, letter C. Now we're going to evaluate the rate of change at a specific point, at a specific value. Evaluate the rate of change when the radius is 5 inches. When r equals 5 inches. Now make sure you use units here, okay? I'm pretty particular about units. I will mark you off a little bit if you don't use the correct units. So then the rate of change, dA dr, is equal to, you just plug 5 in. 2 times pi times 5. So that would be 10 pi. And you could leave it like that. Okay, you could also multiply by pi if you wanted to. And this is the change in area over the radius. So what would that be? Inches squared per inch. Change in area over the change in radius. Yeah.
Is this the first part of the A part of the problem?
Oh, that was letter C.
The whole thing? That's just C?
Yeah. So A was write the circle area, and then find the instantaneous rate of change, and then evaluate.
Isn't inches squared per inch the same as inches?
Yeah, I was going to say that.
Does that make a difference?
I don't know. I was thinking that too. I'm not sure. They always write it like that though. Do you think it's just inches?
Yeah, because
It's just the change in the area over the change in radius is inches? I don't know. That's a good question. When we get to the problems later on, when you have to find the change over time, that'll be better. Like inches squared per second or something. Okay. Let's do number 2 now. Let's go ahead and find the change in the volume. Do you know any volumes? I forget these. Change in volume of a spherical balloon. Okay, so it's not an oval, it's an actual sphere. We're going to change when the radius is 2 feet. That's a big balloon. Right? You're blowing up this balloon, right? So it's changing in its volume. And we're trying to find the change in the volume when it's exactly radius of 2 feet. Now, do you know the volume of a sphere? You do? What is it? Did you have to Google it? No? 4/3 pi r cubed. How'd you remember that? That's pretty good. AP Bio. Really? You know that for AP Bio?
The TV show
Why?
or the class?
The class.
Oh, okay.
Why?
The TV show? We're doing
Yeah.
surface
Yeah,
area
dude, it's
versus
funny.
volume.
Oh, okay.
wait, as far as you know the formulas?
Sometimes. I'm not good at memorizing stuff. I don't even know half your names.
Are you going to give it to us?
Here we go.
What's it called?
I give myself till Christmas to learn all my students' names. Yeah, I give it to you usually. Yeah.
What's my name?
Oh, how can I forget? All right, dV/dr. Change in volume. Change in radius. All right, so here we go. We're going to take the derivative. So we're going to bring the 3 down, and we get 4 pi r squared. So let's go ahead and find it when r equals 2. So you bring the 3 down. 3 times 4/3 is 4, and then subtract 1 off. Pi is a number. Pi is a constant. Okay? This whole thing right here is a constant. This is my variable, r cubed. So I bring it down, multiply times the constant, subtract 1 off. See why I told you it's so important that you know derivatives? Like, because we're going to apply them. And this is like just the tip of the iceberg. Everything else is like crazy after this. Okay, so 2 goes in, and we get 2 squared is 4. 4 times 4 is 16. So it's 16 pi. Change in volume would be cubic inches per inch. So per inch of the balloon that the radius is doing, the volume is changing at 16 pi cubic inches.
Isn't it feet?
Oh, it's feet, you're right.
Oh.
Oh!
Whoa.
First mistake ever. Yeah, right. Okay. All right, so you feel pretty good about these. You know, you just take the derivative, plug it in. I mean, it's that easy. All right, let's go on then to part C. Part B. Sorry, part B.
Another mistake?
Yeah, oopsies. Oh, people be calling me out today, huh? All right, now we're going to look at velocity graphs. I wonder if I should do this second. Yeah, let's just do velocity. We're going to do the graph second.
Come on, that's a third mistake.
All right, nope, I didn't write it though. Okay, here we go. So we're going to talk about velocity, and I don't know if you've done some of this in physics, you might have. But I have it laid out pretty easy for you. So here we go. F of x is going to be the motion of an object. Okay? Sometimes we're going to be on a straight line walking back and forth. Sometimes it's a rock that's fallen off a cliff, or sometimes it's a water balloon that you throw, or I don't know, whatever. It's the motion of an object, okay? When you take the first derivative of that, you end up getting its instantaneous velocity. Instantaneous velocity, okay? You can find the average velocity by finding just the slope of the line that goes through the 2 points. But instantaneous velocity, you need the derivative. Sometimes velocity is negative, sometimes it's positive, right? If you're going backwards, it's negative. If you're going forward, it's positive. Or if you're like going down towards Earth, it's negative, stuff like that. Okay. And then if you take the second derivative, that's the change in velocity. So if you picture like the change in velocity is going to be, do you know? Acceleration. It's the acceleration of the object. Okay? And then speed, the speed of the object is always going to be the absolute value of the velocity. Okay? So speed is always a positive number. If I'm driving out of my driveway at 5 miles per hour, I'm not going negative 5 miles per hour. I'm still going 5 miles per hour, but in a backwards motion. Okay? Velocity, though, can be negative, but speed cannot. All right, and then a couple more things, 2 more. Displacement. You don't like these words? Displacement is going to just basically be y2 minus y1, how far you've traveled. And then average velocity, which I spoke about a minute ago. Average velocity is just going to be the change in y over the change in x. It's just slope formula. Okay? So it's just going to be y2 minus y1 over x2 minus x1. All right. Whew. Are you ready to do one? Here we go. Now these are the type of problems that have A, B, C, D, E, F, G type of thing. Okay. Okay. You just lay down like everything?
No, it's just math.
Oh.
It's just math. What else?
Just math. Oh. Yeah. All right. Here we go. Let's say that we have a particle moves along a line so that S of t equals t squared minus 4t plus 3. Okay, so that's the motion of this object. S is in meters. Bless you. S is in meters, and T is in seconds. There we go. Okay, so here we go. Letter A. We're going to do a whole bunch of these. We're going to find the displacement over the first 5 seconds. Find the displacement over the first 5 seconds. First 5 seconds. Okay, so that's going to be the change in y. So what you're going to do over the first 5 seconds is you're going to do s of 5 minus s of 0. So sometimes you might get stuck like, how am I going to find the displacement when I only have one time? Well, you start at 0. T equals 0 seconds. So over the first 5 seconds, it's s of 5 minus s of t. So you can get your calculator out and do that if you need to. You're just plugging 5 in, and you get 8. And then you plug 0 in, and you get 3. And so the displacement would be 5 meters. That's how much it's moved, how far it's gone in the first 5 seconds. Okay? Now, letter B. Here's the follow-up question. Find the average velocity. So if you've gone 5 meters in 5 seconds, what's your average velocity there? 1, yeah. So that would be the change. See, what you're doing for average velocity is s of 5 minus s of 0 over 5 minus 0. It's just y2 minus y1 over x2 minus x1. And so you get 5 over 5, so that would be 1 meter per second, which should make sense. You've gone 5 meters in 5 seconds. You're averaging a meter per second. Now that doesn't mean that, the first meter you might have been going really fast and then you slow down. It's just your average. All right, so now here come the calculus questions, because that's all, algebra. We are now going to find the actual velocity, the instantaneous velocity. We're going to find the velocity at t equals 4. 4 seconds. Okay, so your average from 0 to 5 is 1 meter per second, but what was it actually going at exactly 4 seconds? Was it going faster? Was it going slower? We'll find out. Okay, so we would do, to find the instantaneous velocity, you're going to take the first derivative of the motion of the object. So take the derivative, see, and this one's an easy one to take the derivative, right? What do you get? 2t minus 4?
Yep.
Okay, and then now plug in 4. We get 8 minus 4, and so it was going 4 meters per second. So it was speeding up, huh? It's going pretty fast. And your average was 1 meter per second. At t equals 4, it was going 4 meters per second. So it started off pretty slow. All right, now let's go ahead and find the acceleration at t equals 4. Find the acceleration at t equals 4. Now the acceleration for this function is going to be just a constant. And so when you find the acceleration, you're going to find the second derivative. So go back to the first derivative, and what do you get? 2. And what's acceleration? That's meters squared per second? Meters per second squared. I always mess that up. See, here's where I didn't take physics, and I wish I would have. Especially the first year I taught this. I was over and talking to my dad. He helped me a lot through this. Okay. Now, here's the next question. Letter E is going to be, at what value of t does the particle change direction? At what value does it change direction? Yes. Very good. Change direction. Okay? This is good. So you're going along a line, and then you go back and you change direction. You walk back the other way. Okay? So you're going forward, and then all of a sudden you go backwards. You're walking a long line. Okay? So when does it change? And you set that equal to 0, because that's when your velocity is 0, right? When you go, well, you should. If you're going to go in reverse, and then you have to stop, and then you go forward, right? You shouldn't just kick it forward, and that really hurts your car, I think. or do what Ryan did and just back into someone. You know, like that's terrible. All right.
That was hilarious, though.
Did you see it?
Yeah.
No, that's sad. Okay, so let's go and set
About 5% Jonas.
our set our derivative equal to 0 and solve.
Oh, we're saying that the derivative is
Yeah. So you wanna, if you wanna find out when it changes direction, you wanna find out when the velocity is equal to 0. And we get that that happens at 2 seconds. Perfect. Nice. Okay, that's pretty good, huh?
Is that happening?
That was section 1 of 8.
All right, we're gonna do another one. Same idea,
Is this?
just a little bit different because I'm gonna ask you some different questions on the next one. So this is still the same, part B, number 4. Part C is short though. Okay, this one has a lot of questions, but I wanna make sure you really get this down. All right, now we're gonna do some vertical motion. So we're gonna be on an XY plane. Okay, so it says that a dynamic blast sends a rock into the air with the motion h of t equals 160t minus 16t squared. Okay, describing the height in feet. The height in feet. And t is in seconds. Seconds, okay? All right, so there's a rock, it's on the ground, a dynamical blast sends it, and you can kind of picture that, right? You could also graph it if you wanted to, but we're going to use calculus to solve all these questions. So it's a parabola, an upside down parabola. So here we go. Letter A. How high will the rock go? Now, the initial velocity is 160 feet per second. How high will the rock go? There are lots of ways to find out this answer. Talked about this in one of my grad school classes. He said, how would you find out this answer? And the Algebra 1 people were like, oh, you just find the vertex of the parabola by doing negative b over 2a. You know, the graphing calculator people were like, oh, I graph it, find the maximum on my calculator. I teach calculus, so I was like, oh, you take the derivative set equal to 0, right? Let's say you don't have a calculator. So I would take the derivative of this, and I'd get 160 minus 32t, and then you would take that and set it equal to 0.
But we will have our calculator.
Maybe. This is such a good way to find the maximum minimum of a parabola. It's great.
Waste some time then, I guess.
I know. Well, like even when I teach this in Algebra 2 and I'm like, do negative b over 2a, I'm just thinking I would just take the derivative, set equals 0. But, all right, 32t equals 160, 5. Okay, 5 is not the height though. 5 is the time. Yeah, so,
Wait, wouldn't it be negative 5?
no.
No.
You add 32t.
Oh my god.
So t equals 5 seconds. So 5 seconds. And then we have to find the height. So you got to plug it back in. So we'll go h of t. Remember, h of t is the height of the rock. And you do 160 times 5. And you know, I couldn't not give you your calculator for this. So you'd have your calculator. And then you get 400 feet. Okay? So that's the maximum height that the rock goes. Now, we're going to answer some calculus questions. This you will need the derivative for. You didn't need it for that one, obviously, if you found it on your calculator or whatever. But this one you will. So the question is going to be, what is the velocity when the rock is 256 feet above ground? So what is the velocity when the rock is, how much did I say? 256. 256 feet above ground. Okay. We're finding the instantaneous velocity here. Finding it at a specific point. Now, if I reach a total of 400 right here, and I'm trying to find out when it's 256, guess what? How many answers am I going to get? 2. Okay, so I need to find out at what time that happens. Yeah. So, if I want to find the instantaneous velocity, I already took the derivative. So I have h prime of t equals, what did we say it was? 160 minus 32t?
Yeah.
Okay. So if I want to find it at 256 feet, I can't plug 256 in here. I have to find the time. So yeah, so now what we're going to do is we have to set the equation equal to 256 and find out what time. Not the h prime, not the velocity equation, but your original equation. So the original equation is 160 t minus 16 t squared, and we have to set that equal to 256. Now you get to solve a quadratic. So bring everybody over to one side. I'm going to bring them over to the 256 side so that my negative 16t squared is going to be positive. So I have 16t squared minus 160t plus 256 equals 0. Is everyone okay with that? And then you get your calculator out and you use your quadratic formula program that you have. Do you have that program? Do I have that program? I do.
Negative b plus or minus b squared minus 4c all over 2.
Yeah. So A is what? 16.
Wait, how do you do
Why
that?
wouldn't you factor out the 16?
You can. I would totally do it that way. I'm just doing it the Hayden way. And I get 8 and 2. Done.
Wait, how do you do the thing in the calculator?
It's a program.
Oh,
Do you not have it?
I don't know.
I can link it to you later.
Can you really?
Oh, sure. It doesn't? Let's delete it and we'll do a new one. Okay.
Yeah, the only one I have is
All right. Or, yes, Kyla, I would have done that. I would have factored out a 16. I think I did that on my paper. And then I would have gotten t squared minus 10t plus 16 equals 0. And then you factor that as t, what times what 16 adds up to negative 10? Negative 8, negative 2. And so we get t equals at 2 seconds and at 8 seconds. So that's when the rock is at 256 feet. I haven't answered the question I've asked yet. What's the velocity?
Don't you have to plug this in?
Yeah, you plug it in.
The derivative?
Yep. So you're going to do h prime of 2. H prime of 2 gives me, you plug it in, you go 160 minus 32 times 2. 96? 96 feet per second. Okay, velocity is a rate. It's a speed. So the rock's going 96 feet per second. That's the instantaneous, that's the slope of the tangent on the way up. And what about on the way down?
Oh, I got it. Opposite. Yeah, this is the negative 96.
8?
It's wrong.
This is wrong?
No, mine. I got negative 96 for this.
Oh, you plugged in 8 first. Because you'll get negative 96
Yeah,
for
I
that.
got that.
Okay,
Oh, what?
but not at 2.
No,
One-
yeah.
So it comes down.
And that's, yeah, it's coming down.
Oh,
So yeah, if we go back to our graph right here, this has an instantaneous rate of change of 96. This has the opposite. It's coming back down to Earth.
yeah.
Pretty cool, huh? Don't you love this stuff?
I actually
Totally like geeking out on it. Yeah, you're like paying attention to everything. All right, letter C.
Oh my gosh.
Yeah.
So what velocity when the rock above, so it'd be both of the answers?
Yes, because the velocity when it hits 256, there's 2 points when it's 256 above ground. See, it starts at 0, it goes up to 400, so it hits 256, and then it goes back down to 0, it hits 256 on the way back down. So you get, that's why when you take the, or when you do this as a quadratic, you get 2 answers. Okay, letter C. What's the acceleration of this thing at any time? The acceleration is constant.
So it's the F, like, prime 2, right?
Yes, it's prime 2. So h double prime of t, the acceleration is negative 32 feet per second squared. Now the first time I saw that, I was like, why is the acceleration negative? And it's because of this. On your way up, the rock is slowing down. Right? It is. You see it? It's going fast at first. The blast, explodes it, and then it just kind of, it's slowing down. But then on the way down, it's picking up speed. So it's like a positive times a negative. So that's why the acceleration is always negative. It's pretty good. I like it. All right. And then, here's a nice question. Letter D. How long is the rock aloft?
Sam.
How long is the rock aloft? Aloft is a really fun word to use. Try using it in a sentence. Yeah. I hate the word aloft. Used it. Okay. How long is the rock aloft? That means how long did it stay in the air for? And this one's actually really easy to find because since it blasted from the ground, it's symmetric here. So it took 5 seconds to hit the maximum. Guess what? It's going to take 5 seconds again. Now, if it starts at 2 feet above the ground, like if you're hitting a baseball, you don't hit a baseball off the ground, then, it wouldn't be symmetric. So be careful of that. Don't always think that it's just going to be double. In this case, it is. So the rock was aloft for exactly 10 seconds. If you couldn't find that, you would set the, it's h of t here. You would set the height equal to 0 and solve. Okay? You would set the height equal to 0 and solve. All right, and then the last question. How fast was it traveling when it hit the ground? How fast when it hit the ground? So here, what you're going to do is you want to find h prime of 0. No, 10, sorry, 10. So at t equals 10 seconds, you want to find out how fast it was going. So that's the instantaneous velocity at exactly 10 seconds. You're going to plug 10 into your velocity equation, which is the first derivative. So what do you get? 160 minus 32 times 10. Yeah? So negative 160 feet per second. It was speeding up pretty quick. And by the way, if you notice in the equation, h of t, here's the equation. I don't know if anyone's ever told you this, but the equation is, it's negative what? 1/2 gt squared plus v sub 0 t plus s sub 0. We did this in Ham. Okay, g is the, acceleration due to gravity. V sub 0 is your initial velocity. S sub 0 is your initial height. So in this case, it was 0. The initial velocity of this was 160. Where's that at? Right here. It's next to t. The initial velocity is positive 160. When it hits the ground, well, you know what it was? Negative 160. So cool. Yeah?
For letter E, how'd you get 10 again?
Oh, for this problem, all I did was just double 5 because it was symmetric since it went through the origin. 5 was the maximum height, so it was going to be 5 to here, 5 to there. That makes 10. Otherwise, you would have to set it equal to 0 and solve.
Okay.
Yeah.
What would you set equal to 0?
You'd set the height equal to 0. So that if the height's 0, you'll find out that t is 0, and then you'll also find out that t is 10. So like this. So it was 160t minus 16t squared. If we set that equal to 0 and solve, we can factor out a negative 16t, and then you get t minus 10. So it's 0 at 0. It's on the ground. And then it's also 10, so it's in the air for 10 seconds total. Okay? All right, last part. You're hanging in there today. We just hit almost 30 minutes, so... Okay, last part is going to be velocity graphs. Okay? And this might be your first time looking at a graph and not looking at the motion of an object. You're looking at its velocity instead. So these get a little confusing, okay? So we're going to draw a graph. And I want you to just kind of bear with me on this one. All right, here we go. So let's say that this is 3 and this is negative 3. And then I have 1, 2, 3, 4, 5, 6, 7, 8, and then 9. All right, we can label all of them. Just label a couple of them, doesn't matter. And then here's what our graph's going to look like. It's going to start at 0, 0. And then at 2, it's going to be up here at 3. And then it's going to go through 0 at 3. And then at 4, it's going to go straight across till you get to 6. And then it's going to go through 7. Oh, not through 7. It's going to go to 7. And then to 9. So try drawing that if you can. And then we're going to talk about this. Now this is the equation, the velocity of t. You really can think of it like as y prime. Okay? Y prime. It's a velocity graph. All right, so I'm going to ask you some questions. Here we go. Are you ready? I don't want to miss anybody. Yeah. All right, when does the particle move forward? When does the particle move forward?
Anything above the x-axis.
Exactly. Are you in physics? No, you decided not to take physics. Okay, the particle is moving forward when the velocity is greater than 0. Okay? So this thing is moving forward from 0 to 3. Okay, above the x-axis. All right? So you can write that a couple of different ways. Let me go forward as like green, because green's nice, like you're moving. Okay? So that would be, and you would say, you know, from 0 to 3. If you wanted, you shouldn't include 0, because at 0 you're not going forward. So you're going forward whenever the curve is above the x-axis. All right, second question. Letter B. When are you standing still?
Isn't it third
Yeah. Okay, good. You guys are good. So you stand still when the velocity is 0. Okay? So when v of t is equal to 0, that's when you're standing still. You're not going anywhere. Velocity is like a speed. So you stand still at t equals 3, and then you stand still from 7 to 8. 7 to 9, sorry.
Where did you stand still at the word computer?
Yeah, I guess you could say that. Equals 0, 3, and from 7 to 9.
Yep.
There we go.
Wait, how'd you get 3? How does it go secret file?
Yeah.
Okay.
So you're moving forward above the x-axis, and then you start to move backwards. Okay? All right, so now let's take a look at letter C. When am I moving backwards?
Below.
Anywhere below the x-axis, yeah. Now, even here, people think, they'll get mixed up. They'll think, okay, I'm moving backwards below the x-axis, but not here. But no, that's not 0. That's just you're moving at a constant rate. See here, you're speeding up backwards. Okay, you're going -1 here, then you're going -2, and then you're going -3, and then you go -3 for 4 to 5, 6 seconds. Okay, and then you start speeding, or you start slowing down, but you're still going backwards. You get that? Okay, so backwards is from 3 to 7. All right, was there any other questions?
Section
I think that's it. Oh, no, one more. Yeah, this one's important. Okay, when is your acceleration positive? When is your acceleration positive? Okay. We kind of just talked about that. Your acceleration is positive from 0 to 2.
It just increases it.
Mm-hmm.
So,
0 to 2. You could write it like that if you want to. You could write 0 to 2, like that.
67.
Yeah, your acceleration is negative from 2 to 4. It's just the slope of, see, because acceleration is the derivative of the velocity. So you just look at the slopes, basically, for this question. It's negative from 2 to 4. And then the acceleration is constant from constant from what? What was that again? 4 to 6?
Acceleration is always constant, right? It's just,
No, not on this graph.
Because it's not.
it's just 0. It's not that it's constant. It's 0 constant.
Oh, 0 from 7 to 9. It's not, it would be constant there.
Yeah, 4, 6, and 7,
From
9.
0 to 2, it's still constant. It's just a constant positive number.
Oh, right. Yeah, you're right. Constant. Yeah, I meant acceleration is 0, not constant. You're right. When is acceleration 0? Constant's not the right question to ask. So
So
from
when does it remain 0?
7 to 9, and also from
Or,
4 to 6.
Yeah.
Yeah. These are hard. I get messed up because I'm so used to like the motion graph, and I always answer it from there. Is this what messed you up too? This is horrible, huh? I know.